need to know some basic items for the fishery oceanographic investigation. First, maybe you hope to know the topographic the variation. So this observation maybe include like the water depth, maybe the sediment survey, something like that. In this observation, maybe the acoustic method is a good tool for this object. And maybe sometimes you need, you can consider to use the drag to correct the sediment. In this slide lower panel, these two figure is the typical the acoustic image. From the image, you can see the acoustic energy transfer from the surface to the bottom. And in the right side, that is the example for the similar the EK500 system using the two frequency 120 and 38 kilometer. So from this figure, maybe you can see the some parameter like the topographical contact from the acoustic system. So the acoustic idea is like this slide. Actually, is maybe early to the 1935, something like that. The active fishery or the academics, the research, they hope to detect the depth or maybe hope to detect the fishing school. And this slide shows the idea is the acoustic data from the 1980 to 1991, the two international conferences like the Scientific Committee on Oceanic Research or the GLOBEC. It's a international project for global ocean ecosystem dynamic. They suggest the ecosystem is the good academic tool to try to evaluate the ecosystem dynamic. Like this figure is we can mount the acoustic system on the research vessel or the fishing vessel. From the acoustic signal, they can transfer from the surface to the maybe to the bottom. So if the fishing or if the fishing school, fish school or the marine life, they stay in the waters, there's the energy will backscatter to the acoustic system. So from the right side, you can see the acoustic signal will be transferred from the surface to the water. From here, we can see here varies the significant signal like the green color letter. This green color letter in general is like we call the sound scattering letter. Due to its depth, sometimes we can call it the deep scattering letter. We call the DSL. Like that, maybe we can try to use the acoustic system to detect like the depth. Sometimes we can cut the fishing school where they stay and easy to catch by the like the fishing gear, depending on which kind of fisheries. So this slide is I said just a few minutes tell you this slide is the echograms of spawning code. This observation was made on a Norwegian's research vessel and published in 1935. So from this figure, maybe we can find where the echoes from code. So for fishermen or the academic research, they can easy to find where the marine life like code. They like to stay, which is later. Maybe we can easy to sample or catch the code, and we can see the green line indicated the button echoes, so we can easily understand the topographic depth from the acoustic data. So due to the computer science promotion, so we can easy to integration the echo signals. So in 1980 years, the echo integration method was developed, and this method can provide the theoretical base of quantitative fission biomass estimation. Like this slide, right side, we can get the signal very close to the button. We can, based on the acoustic signal, and try to integration the echogram, and based on there's the backscattering strength, and we can estimate the biomass. So we can use the acoustic methodology. We can easy to understand the topographic, and maybe we can do some work for estimated the fish school, or there's the abundance of biomass. So this is the first item maybe you need to do when you do some FO, Fisheries Oceanographic investigation. So here is the one example our example for the sound scattering in the crucial regions in east of Taiwan. This slide is show around 36 hours the time series observation for the sound scattering. From this figure, maybe we can easy to find the crucial region. They have two significant sound scattering data. In general, we can call that is DSL. Here has two DSLs signal at 400 to 500 depths, and 600 to the 700 depths. And we can, from the acoustic signal, understand there is the strength like the minus 71.2 decibel in the depth 400 to 500 meter. And another is to the minus 78.2 decibel in the depth 600 to the 700 meter depth. So from this two signal, we can see the first DSL, they have the significant diurnal vertical migration for the first deep scattering data. So and the second is the DSL. Maybe they stay in the deep later all the days. So we can based on this acoustic signal and to understand the marine life the behavior in the waters. So another example is from the Pristin's Columbia's research work. They are focused on the sea mountains observation, and they think that this is a good the fish habitat place. So they try to use the acoustic method to detecting where the sea mount. And so maybe it is a good indicator to find like the fishing ground. So we use the acoustic methodology. Maybe it's the good methodology for fisheries oceanography. And the second items, I think maybe we need to do some like the temperature observation because this information is very useful information for detection the fishing ground. If we can get the sea temperature, maybe we can get some information like the warm or cold core or the thermal front, or maybe the vertical structure like the thermal crine or the mixed layer depth. So however, the maybe your object depend on you design. So we maybe have a different station. How to say the station design, and like this slide lower panel, this is a fixed station for the same place from the maybe from the May to next June. So this is as a monthly vertical temperature structure. So from this fixed station monthly vertical structure, we can see the thermal crest formation from the maybe from the July to August, and follow to the time go through the months. So we can see the in August to November or December, the water is very mixed completely. So we can see in the December to the January, we are hard to see the summer crime, and follow the time, go to the next maybe April to the May, and then the summer crime formation again. So the temperature observation is most important for the fishery oceanography investigation. And there's the information is also important for the fishery. Like this slide is their relation for the Pristina. In the up panel, this slide show the deep. Here has a deep thermal crime. So if the deep thermal crime, it means the mixed layer depth is deeper. So the fish school, maybe they can easily dive out of the Pristina before the Pristina operating. So However, in the shallow mixed layer depth condition, like the lower panel, the fish school, it did not easy to dive into the deep water due to the mixed layer lower area is the summer price the place. So the up and the lower panel they have a big the temperature difference. So deep water they have cool water. So the fish school did not like to dive into the deep water. So we can use the procedure to catch the fishing school in the shallow summer price conditions. So as I said early, maybe based on your object, this slide shows the Taiwan's project like the we call the Taiwan Cooperated Oceanic and Fishery Investigation. This job is conducted from the Taiwan Fishery Research Institute. They try to understand the environment, the change and the basic biological observation, like the zooplankton or fish larvae abundance. They try to do this work for 63 stations observation around of Taiwan by season. And this slide shows another example is for the long-term observation for East China Sea. This is because the good how to say the big experience design due to the mainland China. They try to build up the Yangtze River dam. This dam was built up in 2002. So in East China Sea is the good the fishing ground. So if we have built up a dam in the Yangtze River, so maybe the river into the ocean maybe will be modified. So this job is try to investigate the difference before and after when the dam built up in 2002. So from this figure, we can see the our data in 1998 and 1994, 7, 8, 9, and 10. Exclude 2010. Others years, we had to see the cold water into the cold river water into the ocean. So we can, based on this station design, can easy to understand not easy to understand, but we can to investigate the ecosystem dynamic in the East China Sea. And this slide is follow the ROREX project. We focus on the water close to the Taiwan, in the north of waters of Taiwan. We can see the right panel. They have the good west boundaries current in West Pacific. We in general we call this the west boundary current is the crucial current or the crucial water. From this crucial water is generally move from the south to north when it goes through the east of Taiwan, due to the topographic issues, when it reach to the north waters of Taiwan, the current will be moved to the northeast direction, and some subwaters due to the depth change, the water will be moved to the continental shelf. So in these waters, we generally like to say the crucial edges exchange area. So in Taiwan's the ocean research work, they and include me, we do a long-term observation for the crucial edge exchange observation. So we call this the keep the project. So we can, based on our object, try to understand what's happened when the crucial intrusion or the receding away from the continental shelf. So like this slide, we can see there's the vertical structure from this figure, and this figure shows the vertical profile of temperature and the salinity from our observation during the I think it's winter time, and during the winter time, we can easy to find the crucial water is warm current, and when it meets to the continental shelf water, it should be a big the temperature difference or the temperature boundary. This boundary we can call that is the summer front, and we practice the area in using the black square. So from this slide, we can see in 2012 November to the 2013 March, this the upwind is we can see the blue waters from the deep water move to the surface, and we can easy to see the temperature is different. So we can easy to identify where is the boundary of the temperature difference. So back this the investigation, maybe we can long-term observation from the 2005 to 2014, and then we can easy to understand the oceanic variation for the crucial intrusion to the continental shelf. So this is depend on your object you would like to do. And the next slide, I would like to introduce the sea surface temperature from based on the remote sensing data and the field observation by the research vessel. This slide is the example from the ocean research number 3, conducted from the Sun Yat-sen University in the southern Taiwan. They use the transaction survey for investigated the upwelling zone of the Taiwan Bank in the southern waters of Taiwan Strait. So from this figure, we can easy to see the sea surface temperature and another sea surface temperatures the front as image it is matched up to the temperature vertical structure and the salinity vertical structures. So we can, based on this satellite and the field observation, to detect where the location of upwelling. And another example is like this slide is another example is also conduct from the Ocean Research number 3, and they also use the sea conductive temperature and depth transaction survey and try to detect the upwelling area. In the depth figures, it shows the sea substantial front and the transaction line. And the right side, it shows the vertical structure of the temperature and the salinity. And so we can easily identify similar the that's the slide show, and we can identify the sea surface temperature front and the upwelling area. So the third items, maybe we suggest we can consider to do the current observation. Current observation maybe like it can include the tide or the front or the eddy, like that. This slide is show the example from the Japan's Fishery Information Service Center. This center, they try to show the good information for the fishermen. This slide show the they use different color and arrow to show the like the crucial warm current or the Oyasho cold current, and due to the warm water is crucial meet with the Oyasho cold current, they will be like early 2 or 3 slides said, the temperature big difference is the thermal front. So we can easy to see the warm water, cold water, and the front, and due to the physical dynamic something, we can also see the warm chlorine or cold chlorine. Due to this, the current observation, maybe we can see some good the position to identify the good fishing ground, like the mackerel or the squid, something like that. If you are interested, that maybe you can see some journal or journal paper. You can easily to find their relation fishing ground to the thermal front or the cold or warm eddy. So here I also give to another example to the current observation. This is a spatial observation for crucial mandarin. This crucial mandarin is not easy to how to say to happen. However, in 2017, Japanese the Fishery Information Service Center, they announced this Mandarin is happened, and actually since the 50 years, they are totally maybe just only 6 times the crucial mandarins happen, and this is the second bigger the crucial mandarin happened in 2017 till to now. In the right side panel is how to say the crucial waters meet with the Oyasho current, and in this water is the good place for the soil. Pacific soil is good commercial fish catch by the Taiwan and China and Japan and Korea's fishing boat. And for Taiwan fishermen, we try to use the torchlight to catch the Pacific sorry. And this sorry, they like to follow the Oyashio current from the almost how to say the Hokkaido area move to the south and follow the Oyashio current. Very close to the east coast of Japan. So their study found the Pacific sorry, they have the two migrations the pattern. One is offshore mode, another is nearshore mode. The offshore mode and the nearshore mode is depend on the crucial current. There's the migration. So if this migration is moved to the south or moves to the north, will be, it means the close to the coast or far away the coast. So these two kind of mode will be influence the migration of Pacific sorry. So they will also subsequently impact on the fishing catch for Pacific sorry. So if this current was changed, we also can use the remote sensing like the sea subtemperature to detect the the crucial Mandarin. The crucial Mandarin, maybe we can to identify the water is far away and near to the 32° north between the 136 to 140 east area. So we can easily use the weekly the sea subtemperature can to detect this crucial Mandarin in 2018. So it excludes the crucial Mandarin. Maybe we can also use the remote sensing to detect the like the I said earlier the warm or cold eddy. This slide is from the biological oceanography remote sensing book. They show the first the ocean colors image from the coastal zone. Color scanner, sea surface chlorophyll is the image. From this image, maybe we can easy to see the low production waters in the blue color, and the cool nutrients, the rich shale waters will be located in the shalp waters and the inshore area. So the current observation maybe also can do some other application for to detect the like the mesoscale eddy. This slide is a paper from the Scientific Report 2018. It tries to show the physical and the biological rule of mesoscale eddies to the Japanese ears, larvae behavior. From this figure, we can try to identify the larvae, the dispersal or aggregation in the western North Pacific Ocean area. And the third part, maybe we can to investigate the seawater composition when we do some fishery oceanography investigation. So this part maybe we try to analyze the waters, the waters, the waters, the contents include the organic matter, nutrients, or the pH and the oxygen or others the chemical composition. Like this figure, if we can see the fishing marine life, they maybe like to stay the optimus oxygen contains area. When the minimus the oxygen later happen, the fishing school maybe disappear and the marine life maybe move away the water they like to stay. So the seawater composition is also important for the fishery oceanographic investigation. And the last or the 5 part is for correct the biological and the fisheries data, and it maybe the include how to sample the photoplankton and the zooplankton or fishing larvae, something like that. They can use the planktons, the net, for try to understand the biodiversity or the biomass or something like the abundance of plankton. In addition for the fisheries investigation, maybe we need to correct the catch fishing effort and maybe transfer to the like the catch per unit effort CPV is a good index for to show the relative index of abundance. Both the biological and the fishery investigation is important for our work. And this slide is like the I said earlier, which topic you like to do. This slide is try to show we hope to know the species composition and the domain species in the crucial area. From this slide, we can see the we do 19 observation from the north to south, and also do some current observation based on the cluster analysis. We can find the 3 species community. Maybe we can find the 3 major fish species community in the lower figure or the right figure, right table, and maybe we can easy to identify in from this figure. So we can based on the last slide show here, maybe we can identify here have the 4 kind of the species community. Maybe we can call to the crucial A group or the crucial concurrent group or NEC group and the pan-oceanic group. So it's based on the object. You can do some different station observation for the biological sampling. And this example is well-known research work is in California current. This is start from maybe around 1947. Due to the this area is a bigger change for the sardine abundance, like this slide. We can see this is the estimation the biomass for H2 and the fish landings in the California coastal area. From this figure, we can see the biomass of sardine was decreased around 90, maybe 50. So the United States of American government, they found this the sardine abundance of biomass was significant decline. So they hope to try to what happened, and they also do the fishery management in 1967 to 1985. So from this figure, we can see that the balance almost is lower for less than almost maybe 20 years. And so they build up research agency like the Southwest Fishery Center in La Jolla, California. And so this Fishery Research Center is actually they are focused on to study the sardine abundance. So they try to do long-term observation. We call the Carcoffey the study. Actually, we can call the California Cooperative Oceanic Fisheries investigation. In right figure, we can see when they start this project, maybe in 1949, they almost a big job they do, and it is joint research by the California's state government and the NOAA. So this is example their results in 1994. They for the sardines population in April 18 to May 11. And the next slide is for the sardines abundance in 1996. And so they depend on the sea conditions. They maybe have a little change there. The survey observation, and this is slide for the 1997 March. Follow the satellite development. So they try to do the combine the satellite images data. So this slide is try to show their result April 6 to 29, 2000, and April 6 to the March 3, 2001. So from this figure, they also identify the Pacific sardine, North anchovy, and the jack mackerels. They use the different color to show their temporal and spatial distribution. They also try to use the sea glider to understand the transactions, the oceanic conditions variation. So this is an example. They try to collect the data using the unmanned vehicle like the sea glider to do this work. So they combine all the data. Try to do understand the potential sardine habitat And this slide is show the 12 years the sardines the act surveys data from the 1998 to 2009. They also try to use the how to say the static model, generally adaptive model, so they can based on this model to combine the fish egg data and the environment data and to find the sardines the optimize the habitat. For example, they suggest almost 90% sardine larvae they like to stay in the sea temperature between 11.5 to 50.5 degrees Celsius, and chlorophyll between the 0.18 and to the 3.2 milligram per kilometer. So maybe we can easy to find this habitat and do the fisheries management. This is there's the application based on the coffee's the result. And back to our the waters around of Taiwan, I just say early like the this slide we have the direct long-term observation on the East China Sea and the Thai coffee, and that is similar to the coffee. This work is Thai coffee is operated since the 2003. So till now, almost we have the 18 years data. So we try to combine these two objects and try to understand the anchovies, larvae, species composition, and there's the temporal or spatial distribution. Big circle is means the big abundance, and the different color shows the different species like the Ingress japonica and the Ingress common hydrolabo or the Ingress corneous panther, like that. And so we can know that our observation is based on the time scale or the horizontal spatial scale. So it's based on, as I said earlier, which object you like to do. So is in this figure we can see the California's the study is almost continue and less thin for more than maybe 70 years. And if you like to do some study like the ENSO or something like the mesoscale phenomena issues, so you need to consider your object and try to do your planning. So based on our the basic items for the visually oceanographic investigation, actually we know the visually oceanographic is the best science include the visual and the oceanographic. So as I said, the first slide, last two times the application and briefly the introduction to F4, they maybe include some idea and include ocean population study and maybe sustainable fisheries. So if we like to do that work, and maybe we need to how to use the which kind of instrument or method for the visually oceanographic. So here I would like to introduce the first two introduction. fishing instrument, like the instrument for the fish catch and for fish detection, or the how to measuring the oceanic parameter, and maybe for the plankton correction. First, maybe we need to consider we need a research vessel. Like this slide, this slide is our the new vessel in National Taiwan Ocean Research. This is the second ocean research, and the 01 is turned off 2 years ago. And this vessel is length over the overall about 45 meter, and almost their that weight is around 273 tons, and so maybe this research vessel is important tools for the fishery and oceanography study. And in this vessel, maybe we have some basic instrument, like the global position system, and we call the GPS, and maybe like the navigation system. So we can actually to identify where our research vessel's location. And this slide shows the some basic or the basic instrument for the oceanic observation or the biological sampling. And we also do some basic the oceanic observation, like we use in the conductivity and temperature and depth observation to try to observe the vertical structure of oceanic environment. And the basic parameter is like the temperature and the salinity, and maybe like the ozone and fluorescence, and like that. And we also maybe have some portables instrument try to sampling the sediment. And like this slide, we can use the trawler, or maybe use the drag or the piston coil, try to correct the sediment. So this is just the example, like for you to understand how to sampling the sediment. And maybe we can use the different kind of plankton net. This slide is plankton net, and we combine some different mesh-sized small net, and try to replication to correct the biological sample. Others, the plankton net, like the NOPEC, or like the ORI net, is well known sampling net in the research vessel. And we continue to how to do the fish catch. Here is quickly to show some different fishing gear. This slide is download from the website, from the International Standard Statistical classification of fishing gear. So from this slide, maybe we can understand the instrument for fish catch, like the surrounding net or the seine net. And this slide is typical pristine net with the basic construction with particle specification. This case is 292 meter per thinner. And this slide shows the basic construction was thinner and the pitch thin and the bowl thin. So all of them was correct from the website. And this slide shows the net the basic structure. So I think everyone know there's the structures condition. And the next one is the pin trough or button trough or the middle water trough. And the semi-pelagic or the two-ball trough or the tail trough. So here is some example for the trawler. And we also have some different kind of the drag operation or the basic construction for drag. And some maybe traditional deep net, like this three figure. And we also have some the cast net, or maybe use the light to try to catch the fish. We call the random net, like that. And maybe we have some trap, pole and the trap. Maybe we can easy to catch the like the crab or something like that. Yeah. Or something maybe we have a spawning or the chicken. We call the point line and the long line, shift the long line, and the trolley line, something like that. And some traditional fishing gear like the harpoon spears and push net and the diving net, and maybe you can dive in the water to sampling or observe the biodiversity, something like that. And the second part is some kind of maybe we can do the fish detection. Actually, is from the early maybe 3 to 5, something like the slide. We already talked about the using the acoustic methodology to detect the topographic. Actually, there's the additional function is to detect the fish school, like the echo sounder. This is the ideas of echo sounding using the multi-beams echo sounder.
Excuse me, Prof. Lee.
Yes.
Yeah, you have two choices.
Yeah.
Continuing your lecture for 20 minutes, next 20 minutes, or you take a break for 10 minutes.
Okay.
To let the student give you questions, then continue for the next 20 minutes.
Okay.
The second, which one?
Okay.
Which one do you prefer?
Okay, take a break 10 minutes.
Take a break 10 minutes. Okay.
Better is better.
Yeah, okay. Yeah. Okay. Yeah, okay. Yeah, okay. Take a break for 10 minutes. To let the students give you some questions. Yeah, because this is very I think very interesting topic for students, not only for students but also for myself. So let the students give you question. Yeah.
I hope so. I hope so. Yes, I think.
Yeah, Ninda Ramadia. Hello, Ninda.
Hello.
Ask your friends to give question for Prof. Lee. 2 or 3 students. Yeah.
Yes.
Okay. Ask your friends. Ask your friends to give a question for Prof. Lee about the topic. Hello?
Hello? I think.
Yeah.
Any question?
Yeah, okay. Please give question, ladies and gentlemen, my beloved students. Two or three students, you can raise your hands. Ninda will write down your questions. Come on, please.
So, sir.
Yes.
Yeah. Maulana, would you like to give a question?
Yes.
Pak Kuroji? Okay.
Okay.
Ninda, please write down the question from Maulana.
Yes, I'm waiting.
Okay. Okay. Good afternoon, Mr. Lee. I have a question for you. Is mixed depth layer related with sea slope? Does mixed depth layer causes turbulence?
Okay. Roughly, you can. Yeah, you can answer directly. Did you get the question?
Yeah. Again. Yeah. Please.
Yeah. Okay. Ninda, can you repeat? Ninda, question from Maulana. Yeah, Ninda. Or Maulana, please repeat the question.
I will repeat your question.
Yeah, okay.
Yes,
okay.
yes.
Okay. Is mixed deep layer related with sea slope?
Yeah.
Does mixed deep layer causes turbulence?
You mean the mixed layer depths?
Yes.
Yes. So, what's your question is the shallow mixed layer depth is easy to catch fish or not easy? Or mixed layer depth, you hope to know the how to say there is the definition?
Maulana, yeah. Did you ask about the relationship between water layers, yeah, against again the contour of the bottom of the sea? Is that right, Maulana?
Yes, right.
Okay.
In relation with just correlation between yeah.
Yes.
Okay. The mixed layer depth in general is like a homogeneous water mass due to its good the mixed wear from the surface to maybe to the how to dip. So if the mixed layer deeper, it means deep mixed layer depth. If the mixed layer is weak, maybe we have a shallow mixed layer depth. How to observe the mixed layer depth? In general, we can measure temperature. We can measure the temperature 1 degree from the sea surface. For example, the surface temperature is 28, and maybe you can use the Ctd conductive temperature and the depth, the measure to detect the 27 degrees Celsius where or its depth. If we can detect their depth, we can measure the deeper or shallow of the mixed data depth. So how to know the mixed data depth? We can simply to use the temperature structure. The temperature structure is homogeneous, and there will be a stable, or how to say, the mixed data depth. Another idea is maybe you can see the difference between depth and the temperature degree. If you have a big difference temperature over degree, it means this area is the thermal climate. The upper depth, the depth of upper thermal climate is the lower of the mixed data depth. So we can easy to understand the vertical structures using the temperature or the salinity data. So if you can see the thermal climate or the salinity climate, and you can easy to identify the mixed metal depths. Yes. And my explanation is not or did not to match your question.
Yeah, okay, Maulana, I think your question already answered by Prof. Lee. If it is not clear yet, then you can here put this lecture is this online lecture is recorded. You can hear by yourself from this recorded. Okay, Maulana.
Okay, sir.
Yeah. Okay. One more question, please.
Linda, is right?
Yeah.
Yeah.
One more question. No more. Yeah. Come on. Come on, guys. No more questions. Yeah. If you don't have any question, then probably Prof. Lee will continue this lecture for next 20 minutes.
Okay.
Yeah.
Sure.
Okay.
Okay. No
Yeah.
problem.
Okay.
Yeah, sure.
Okay. Time is yours.
Okay. Sure. As I said that early, how to detect the fish school. So this slide is, I think you already saw that in maybe first 5 to 7, something like the slide. So from this figure, the DSL, you change to the fish school, maybe you can understand where the school stay and their boundaries. So acoustic is a good the tool to detect the fish. And maybe we also need some instrument for measuring the oceanic parameter. Actually, I told the first equipment maybe is research vessel, and we need some instrument mounted in the research vessel. Like this slide, this is the Ctd system. This Ctd system, maybe they can have some accessories equipment Preliminary equipment is the temperature and the salinity sensor, and the pressure sensor. It can to detect the depth. In addition, is the sensor, maybe you can to detect the like the water clarity or the bioluminescence or the current like you using the acoustic ADCP acoustic Doppler profile the sensor like that. So in the water, you can use the more instruments for the measuring the oceanic parameters. Like this slide is for the Ctd sensor. So this is the primary tool for determining essential physical properties of sea waters. And like this slide is for the ADCP is acoustic Doppler current profile, and this equipment can mount horizontal on the seawall or the British Pyrenees in river and the canal to measure the current profile from the shore to shore and to the bottom of the ship to take a constant current measurements as the ball boom. And last is for the plankton correction. So as I said earlier, maybe you can or I use the plankton net and some different multi open closed net. And here I introduced the two kind of planktons, the net like the new stones net. This net is try to correct the plankton very near to the surface water. And here is another example is to correct the plankton we call the bongo net is to rinse the plankton net was produced by the German company. And we maybe also have the multi how to say the net we call the MOC-NESS system. And so this system can help the research match what they find in their sample to the physical properties of seawater and the biological sample. Due to maybe they have 6 to the 20 net, so we can show maybe the different vertical depths. So we maybe also have the others video plankton recorder. This is the underwater video microscope system that can take image of plankton or the particle materials. It is automatic. The system try to collect the data. So it's the advantage is they have a high resolution and rapid measurement of the distribution of the plankton text. In the Europe or the United States, they try use the system to do the long-term observation for the plankton's abundance and with theirs the temporal and the spatial distribution, and maybe it's easy to understand their difference influenced by like the environment such as the climate change like that. And finally, is the good method is using by the remote sensing. This is a slide try to show the image. We can use the geostationary satellite or use the parallel satellite. So based on these two kind of satellite, maybe we can gather some the data like the sea subtemperature or the chlorophyll A concentrations, the image or the web condition. And so maybe just in this the future derived from the satellite, we can easy to wide areas the oceanic condition. So how to download the satellite data? These satellites, they have some put different temperature and the spatial resolution. This is based on your satellite different satellite image. So so how to you to download the your satellite data? Some international agencies, they try to do the remote sensing data service. This slide is show the Asia's Pacific Data Research Center. They try to do some remote sensing data service. So maybe you can log in this website like the APDRC. Here have the HTTP web address. As you log in this website, maybe you can select the data icon and try to choose the which kind of satellite you can like to use. Like I said earlier, you can maybe you like to observe the sea temperature. Maybe you choose the like the AVHRR satellite. If you like to choose the analysis the ocean color like the chlorophyll A concentration, maybe you like to choose the CDCS, seaweed or the modest satellite like that. So you can choose the satellite and choose the which area you like to download okay, this is choose the which data source like this slide show you. Maybe you can collect data from the modest aqua sea temperature like that, and then maybe you can display your data. Maybe you can you can choose which kind of data type you like. Maybe you just only like to show the figure, so or you like to use the ASCII code data. So depend on you which kind of data you like to use. So finally is maybe you need to choose the which area you like to, like the area like the latitude and the longitude and data the period, and then you can choose the your output format like the color plot or the day and the time like that. So right now the remote sensing data, I think is very easy to use. When you do your selection, you submit your requirement to this remote sensing service center, and they will quickly reply your requirement. So finally, maybe you like to further analysis, you better to choose the output the format like the ASCII code file. Finally, I try to use the data set to give an example for the sea subtemperature and the profile A image last time. Today I also show this the sea subtemperature and the profile image in here. Like this figure, this is the sea subtemperature from the 2020 September to the 2021 August. This is the monthly the sea subtemperatures in the waters around maybe Java area. So from this figure, you can see in the June to maybe August in the south waters of Java, the temperature was blue color. Blue color is very close to the 26 degrees Celsius. Is a very big difference to the October to the next maybe May. So you can see the June to August the temperature is different to the other season. And if you compare to the profile data at the same months in the south water of Java, the coast water, the color is near to the orange or to the red area. It means that the profile A's crop A the concentration may be less than the 3 or more than the 5 milligram per cubic meter. So this area maybe is I say that maybe last talk it is a phenomenon of upwelling. So if we compare the north and the south side waters of Java area from the July to the October, so maybe you need to consider why and what's reason to let this temperature a big difference between the north and the south waters of Java area. And so actually that is some paper I showed the last talk. It should be influenced by the southeast monsoon. So when the period of southeast monsoon, in general, this area will be offshore. The upwelling will be happen. So it means in the coast waters will be the cold water and with the high chlorophyll or the high nutrient. And so maybe in this time is a good indicator for fishing ground maybe. And it's exclude how to say there are many research remote sensing service like this website was offered by the Euro's remote sensing center. So if you like to use the Europe the satellite data, you can consider to use the G-Web and try to learn how to use the satellite data from this website. So this is my talk whole about the method and to the Fisheries Oceanography the investigation and how to do the data analysis. Maybe we need to consider the your data is belong to the fishery dependent or the independent data. Here I will give you a brief idea is fishery dependent or the independent data. Actually, all the data is come from the fishing boat. It should be the fisheries dependent. if maybe you have the good design or plan, or using the research special, it should be the fishery independent data. Like this slide is the fisheries dependent data, because our data is correct from the fishing boat or the fisherman. So here we can see they have different fishery fishing effort from the gear net, from gear net, the long line, trawler, or the precision. And this slide is another kind of data for fishery independent, because this data is we do a special design for biological sampling. Even we use the fishing boat, and so as we get the fishery or the fishery independent data, maybe we can consider the different kind of statistical analysis. This is the CAMA's statistical analysis module, like we call the GAM analysis module. This module is using the R language to try to build up the statistical model. Actually, as I said, what object you like. So GM just one of the data analysis module. Maybe you can use the other kind of statistical model. Like the last talk, I showed some model like the GMM or the AMM module for the habitat developer. And here we just show the GAM. This slide is show the GM analysis procedure. So maybe we can step by step to do the GM module. But first, maybe you need to build up the match up data between the fishery and the environment data. Like this slide, maybe we have the YY is year, MM is month, and the latitude and longitude data. And maybe we have some environment data like the mixed layer depth and the sea surface height anatomy and the sea subtemperature, something like that. And when you have a location in with the environment, maybe you need to match up one the catch per unit effort. Like the last time we focused on the big eye for focus on the macro, something like that. So as you have this match up data set, and you can do the GM module. And the software and the data file needed to match together. After this, maybe you can cut your result. Before you do that, maybe you can do some how to say your output setting. So we can step by step. Due to this is the data analysis practice. So maybe hard to explain. Anyway, the GM, you can easy to use the GM code and use the R language program, and then the program is easy to use. And finally, is maybe we can understand your model is reached to which kind of the significant level, and understand which kind of contributions percentage for each environment variable. And finally, maybe we can gather your result like this slide in right panel. And after this, maybe we can use the example. Last time I talked about the swimming crab. For the red, blue, and the green crab, here have 3 swimming crab in the Taiwan Strait, and we try to match up the environment for the sea subtemperature and the chlorophyll and like the water depth, something like bottom temperature and the sea surface height, sea surface salinity. And after this, we can gather the GM models result, and we can find these three swimming crab. They have a good result by using the GM result. There's the R-square berry is reached to the 0.1834. So here maybe we can give an example for the red crab. Their result show the red crab. They have a positive correlation with the sea surface temperature when temperature is larger than 20 degrees Celsius, and the chlorophyll A may be larger than the 0.5 milligram per cubic meter. But the red crab may be negative correlation with the when bottom temperature is larger than 15 degrees Celsius, or the sea surface height is larger than 0.6 meter, or the salinity larger than the 33 PSU, or depth larger than the 100 meters. So you can, based on this, the GAM's result, and you can define the optima or the optimal environment area. So this is the one example for data analysis on the red crab's populations, the variation associated with the environment. And maybe you can also say that you can find some optimized environment for red crab by using the GAM. And so last one is I hope to you know that the big the issue is what is your object in the fisheries oceanography. For here is, for example, like the first slide, you want to know the marine life where to live for each stage, something like, or which kind of food they like to eat, or how to obtain, or they how to avoid the predator, something like. So based on your object, maybe you need to do some basic item for investigation. If you have this maybe 4 or 5 basic item, and do optimize the data analysis module, maybe you can get some or new ideas for the fishery oceanographic. Okay, and this is my talk of today. So any question, or you can submit or do something like that. Okay.
Yeah. Okay. Thank you very much, Prof. Lee. Very nice lecture and very good topic. I think it will very useful for us, yeah, especially for students. Okay, guys, my beloved students, please give any questions. If you have something to ask, then raise your hand and address to Prof. Lee, yeah, about fisheries oceanography. Come on. We have about 10 minutes. Yeah, we have about 10 minutes to make you get clarification for the last lecture given by Prof. Lee. Yeah, come on, please. Raise your hand. Don't be hesitate and don't be ashamed. Yeah. Don't think about your English, no problem. Yeah, as long as understandable, it's okay. Yeah, 1 or 2 questions, please.
Maulana, he has question.
Oh, Maulana again.
Yeah.
Okay.
It's right.
Okay.
Okay.
Yeah. Okay, Maulana.
I have a question for you. What is the impact of the SST difference between the north and south side water in Indonesia on fisheries in Indonesia?
You say the sea sub temperature difference?
Yes.
Impact.
The impact.
Impact.
Yes.
Actually, you know, the marine life maybe they have the optimized habitat environment. So the temperature, if you change, maybe they will move to another place they like to stay. For example, maybe for example, maybe big eye. This is just hypothesis. If big eye they like to stay 20 degree, when the waters around the Java maybe 1 or 2 degree, maybe big eye, they will be moved to the deeper or move to the north. In Indonesia, maybe move to the south, something like. So the environment change, like the sea temperature increase or the decrease. Decrease like the maybe in your case in Java south side waters, due to the monsoon physical influence will be that the coast water move to the offshore water. So the deep water will be moved to the surface. So this will be have the upwelling issues. So these upwelling issues may be to let the high nutrient to move to the upwater and surface water, and that the phytoplankton grows up, and the zooplankton also grows up, and the small size fish or the big eye, they have the food to eat. So the first one is maybe we can see the temperature change. So if the temperature change, maybe we can try to find the how to say their habitat maybe shifted to other place. So it is the first issues we need to observe. So as you said, in the north and the south side of Java waters, actually, I suppose the species of composition will be different in the north and the south side. And so it's because of the there's the environment, optimal environment of each species. They are different. So when the temperature is changed, the species may be also influenced by this change. For example, recently we maybe talk about like the climate change issues. Based on some academic paper, they do the how to say it's modeling the simulation. Maybe 40 years later, they use for example, the 2000 maybe 10 to 2020 data, compare maybe to the 2050 to 2060 year. So they found that maybe the temperature is increased. So they suggest in maybe the Earth square area, or we call the low latitude area, to compare to high latitude area. Due to the temperature increase, so some species maybe move to the north or move to the south. In the high latitude area, the fishery catch, there's the simulation result. I say this is simulation result, will be increased maybe 30 to 70%. However, in the low latitude waters, maybe the fishery catch maybe decrease around maybe 40%. So the temperature maybe is important key issues to impact the maybe fishery abundance, catch, or their fishing ground. Okay, maybe I hope my reply you can. It is enough to you. Yeah.
Okay, thank you for that.
I think it's clear enough the answer from Prof. Lee, but the question given by Maulana about the impact differences, the SST differences between north and south of Indonesia waters. Next one, please. One more question. Come on. This is very good chance for you to practice your English, and also to enlarge your knowledge and experience. Guys, come on. Yeah. No one? Yeah. Okay. If no one have a question, let me raise my question for Prof. Lee.
Yes, thank you.
Yeah. Okay, Prof. Lee. According to your presentation, that I saw that there was differences between north of Java, yeah.
Yeah, sure.
In Java Sea and south of Java. In north of Java, it was dominated by brown color about the map, while in south of Java, the color was dominated by blue. What was the cause of this color, roughly, according to your map? Yeah.
This slide?
Yeah, this one. Yeah,
okay,
this one.
Okay.
Yeah.
Okay, you means what's the colors meaning or something like that?
The color, yeah. What the cause? Why in south of Java, yeah, dominated by blue ones, and then the north of Java, some only green and brown. Okay.
Okay. Actually, this is how to say, this is phytoplankton's photosynthesis issues due to the sunlight maybe trigger the chlorophyll to do the photosynthesis. So, but if you try to do the photosynthesis, like the agua or the diatom, they need the nutrient to absorb that. So if you did not have a nutrient, the phytoplankton, they cannot do the photosynthesis and then cannot do growth up. So we use the satellite to detect the different wavelengths, like the maybe 490 nanometer and 550 nanometer. These two wavelengths is good to the chlorophyll A absorptions low and high. So we use the satellite to use the ratio of the 490 over the 550, the ratio to try to do investigate the chlorophyll A concentration. So actually, this image is conducted from the visible wavelength. We call the ocean color satellite. So from the ocean color satellite, we compare the data in situation. Maybe we use the remote, we use the research vessel, go to the seawater to sampling the water and compare the satellite data at the same time. And we maybe develop one algorithm to measure the chlorophyll A concentration. So this figure is conducted from the satellite ocean color data. So if we got the high chlorophyll A data, and then we can based on the good how to say the visible wavelength. So in other words, it means that this water have the high nutrient and that the algal or diatom, they can easily grow up. So if we have a high concentration for nutrient, maybe we have the high density of phytoplankton. So we can use the right panel color bar to show the high to low the chlorophyll A concentration. So in the blue color, it means the maybe orthological water. It means that this blue color is the clean water. It's hard to have the hard to detect the nutrient, but for the coast water with the red to yellow color area, it should be the high nutrient and to support the diatom or phytoplankton to do the photosynthesis and then to grow up. When they grow up, we can detect the wavelength difference from the ocean color satellite. So we can use this idea or methodology to monitor the monthly, temporal, and the spatial distribution of the chlorophyll A concentration. This slide is for the water in south and the north side Java area. Maybe my answer is good reply to your question.
Yeah, I think yeah, your answer is very clear and meet my questions. If there is no more question from students, then I think we almost finished the lecture from Prof. Lee. Yeah, the lecture was extended about a minute, Prof. Lee. Yeah, supposed to be finished at 15 p.m. but now it's already 10 past 3 p.m. It's okay. And very nice lecture. Let me conclude from your lecture that based on your lecture, then we know that there are at least 5 investigations when we go through the fisheries oceanography investigation. They are topographic, temperature, current, seawater, and biological and fisheries investigation. Yeah, this is the clue, the conclusion of your lecture. Yeah, then by learning from your lecture material, then we know that where the life cycle of marine life, and then we know so what food and to be eaten by fish, and then how fish avoid the predator, and where and how and when fish conduct a reproduction. That's all, I think. Very nice lecture. Thanks very much, Prof. Lee. Please, audience, applause for Prof. Lee Min An.
Thank you.
Yeah.
Thank you. Yeah.
Thank you, Prof. Lee. Nice to meet you.
Okay. Bye-bye.
And for the audience, yeah, bye-bye. Okay.
Okay. Bye-bye. Bye-bye.
For the audience, please join the closing ceremony for our 3-in-1 lecture. Probably Prof. Lee also can join. Will be held on 2nd of November at 9 o'clock. Okay.
Okay.
9 o'clock in the morning. Okay. See you all. Prof. Lee, thank you very much. See you all, guys. Ninda as Notulens. Bye.
Bye-bye.